A frog. That's not a polynomial.
But, what makes... Yeah. No. Again, it's not a thing about factoring. It's a question about, is it a polynomial? I can do a lot of things with polynomials, but this question is just asking, is it a polynomial? That's all it's asking. So what makes something not a polynomial? What would happen to make something not a polynomial?
Not a whole number.
Say again?
It's not a whole number.
Not a whole number, no. No.
I have a negative.
It can't have a negative where? In the exponent. I love it. Because polynomial is going to be defined everywhere. So there's the easiest example of something that's not a polynomial is this. You could also write this as x to the negative 1.
That's not.
So a polynomial is something where every variable is raised to a whole number power. That's it. So that excludes negative powers, that excludes fractional powers, which actually turn into roots. So is number 2 a polynomial? I mean number 2b.
No. Yeah.
Look at every variable, or any of the variables, either on the bottom or raised to a non-whole number. There is a fraction in that, but who cares? It's a number. Are there any variables that are raised to a number that's not a whole number? B cubed, 3 is a whole number. B squared, 2 is a whole number. B, 1 is a whole number. Right? Just because it's b over 3 doesn't kill it. If it was 3 over b, that would die. Poor little dude would die. Do you guys get that? So I want a polynomial to be something where every value can be used. So that kind of leads to the fact that it can't have any variables on the bottom. So b is completely a type of polynomial. Yeah.
So we just put yes? Or?
Well, if they're polynomials, if it is, give the type of polynomial, the degree, and the leading coefficient.
How about the leading coefficient is? Because when we did this in our notes, all we did was trinomial or binomial or whatever, and degree.
So the leading coefficient is just what's the number in front of the highest degree term.
Oh.
Yeah, that's like the number that would be in front if you put it in order.
Okay.
Yeah. So like number 2, the leading coefficient is 1.
1.
Mm-hmm.
So,
Yeah, there it is. Cool. All right. Yeah.
I got a question for number 33, section 4 following 3.
Ooh, all right. 4.3. So that's the one that's got x times 8x plus 1 equals 3x squared minus 2x plus 2. Cool. So can I just go x equals something? I mean, this side is factored, but how do we look at this? Somebody factored this side. Should they have factored this side? You sure? What should it be equal to before you factor anything? It should be equal to what? What needs to be on the side for the factoring to actually lead to answers? 0 is the only thing that it could equal to that gives me answers. So somebody factored this too early. So is that side 0? No. So I need to, it's going to sound weird, I need to unfactor this. I need to remultiply it out. Right? So what do I get when I multiply this out? 8x squared. Plus x. See, now you can make this side 0, because now I can move all this stuff over and put the like terms together, right? And what tells me to get this thing equal to 0? What is it? I wouldn't make this equation equal to 0 here if I'm trying to solve it. What's the difference between this equation and that equation? Why would I not set this one equal to 0? Why would I just solve this like I always would, any equation, before we learned this stuff? What is it about this equation that says it doesn't need to be set equal to 0? There's no x squared, there's only x's, right? All my x terms are like terms. I can put them together. This, can I put those together? Shit! So I can't get x by itself. I can't solve it like a traditional equation. So I had to come up with a different way to do it. So when there's a power on your x that's not 1, it's higher than 1, more than likely you got to get that sucker equal to 0 so you can do it. So you can factor it and go from there. All right. So then here you just subtract, add, subtract everything. Why am I doing all that? Because I have a higher power than 1 on my variable. I would know I want to get it equal to 0. So minus, plus, minus. So I get equals 0. All that stuff cancels. I get 5x squared plus 3x minus 2 equals 0.
That's why I was stuck with it.
Now the really, really funny thing is,
I just figured
what's 5 minus 2? I mean, 5 times negative 2 is negative 10, but what's 5 minus 2? Freaking 3. So the answer is staring in your face. Because how do I do this? 5 times negative 2 is negative 10. I need factors that add to be 3. Well, those factors add to be 3. Did you have to notice that? No. You could just not even notice it, just start working with negative 10. But it's nifty to just take a second and see, are these already the answer? You know? So 5 and negative 2, sure enough, multiply to be negative 10. Add to be 3. And what do I do with those numbers now? It's like somebody's like, I'll tell you what to do with those numbers. Huh? Yeah, rewrite the middle term. Make it into 4 terms because then that's relatively easy. Grouping should be relatively easy. So if leave the 5x squared alone, leave the minus 2 alone to break this guy up into, I'm going to put the minus 2 first because I have a choice, minus 2x plus 5x. And it still equals 0. I get both mistakes. If I ask you just to factor something, don't set it equal to 0 out of nowhere. But then if it does equal 0, don't forget that. You have to actually get answers then. Yes, sir?
How do you know who to do first, the minus 2 or the...
It doesn't matter, but if I have a choice, I'm going to make that middle sign positive so I don't make a negative mistake over there. If these were both negative, then I don't have a choice. So, oh well. But it will work either way you do it. I'm just trying to control for the normal place people make mistakes. So then what comes out of these two? X. Now here's what's weird. If nothing comes out, there's always something that comes out. What comes out of every number? 1. And the only reason you do that is so it looks a little more like what you're used to. Right? So how do you factor this? 5x minus 2? X plus 1. Got it. And then you set each one equal to 0. Now you can do that, because I have a number times another number is 0. One of them has to be 0. So you set each one of them equal to 0.
Can you put number 5 on the factorial? 5b.
Oh, alright. Does it open up or down? Okay. What tells me if a polynomial opens up or down? So, yeah, the negative side. So it tells you if a line is going down versus going up. The leading term, if it's negative, it's going down. The slope would be negative, right? So this is not exactly the same thing because the parabola doesn't have the same slope, but that first number being negative, that x squared term, if it's negative, it's going to open down. And real quick, if y equals negative x squared, no matter what I plug in, if I put a 0 in, then y is 0, but everything else, you put a negative 1 in. What's negative 1 squared? Now put a negative 1 in. Bam! You put a 1 in, you get negative 1. You put a 2 in, 2 squared is 4, put a negative 1 in. See, all of these are going to be negative. So what's it going to look like? It's going to have 0, 0, negative 1, it's going to open down. So if that first term is negative, it's going to open down. You got to love that shit. So I know a line is headed down. If it's negative 5x minus 2 or something, it's going to head down, right? So parabola kind of doesn't go down only in one direction. Just everything goes down then. It's always going to be negative. If there's a negative out front, it's going to go, wah! Okay, so let that be nice. That's very related to the slope idea that we already know.
Just put it down.
Yes, cool. Just say down. I like it. Now, how do you always find the y-intercept?
Oh, the last number.
Yeah, in this case, it's the last number because I make x 0. So what's the y-intercept here? Oh, that's a trick question, really. It's not 6, it's 0, 6. Oh. Stupid math teachers and your detail crap. But, the y-intercept is a point. So you can't just give me a number. It's got to be a point. And now, how the hell do you find the x-intercept? Because I didn't just say find the y-intercept. I said find the intercepts. How do I find the y-intercept? I make x 0. So how do I find the x-intercept? I make, where's y? This is y, right? Didn't that function notation take the place of y? So I make this 0. Oh, this looks like, oh shit. Oh shit, that looks like this shit here. Right? I have a function with a square on the x, right? And I already got it equal to 0. So what do I have to do with this side? What do I have to do with this side? What did we do here? Factor. I'm going to factor this bad boy. And I'll give you a little clue. I don't like that negative there. I don't know if you guys agree with me. Basically, we don't like negatives anywhere, but a negative out front really sucks because it's going to screw everything up a little bit. But that 0 can eat everything up. Just divide both sides by negative 1. Right? So if I could, I would divide by a 4, so that wouldn't be there either, but I can't. It doesn't go into these. But I can divide by negative 1. 0, it eats it up. 4x squared plus 5x minus 6. Now that you can factor and find the x-intercepts. And it kind of makes sense. The y-intercept is 6, right? 0, 6. And this opens which way? So how many x-intercepts will it have? It'll have 2. So I don't know if that's not the vertex really, but it's going to open down. So it's going to have 2 x-intercepts. I'm going to get both of them because I'm going to factor this bad boy into 2 parts. They're each going to have an answer. What does that relate to physically, visually, where it hits the x-axis? That's awesome. If I make y 0, it's on the x-axis. It's going to have 2 answers because it's going to hit it twice. So open it down. Bam, it's going to hit that sucker twice. Did you have to know what I just said to really do this problem? No, you didn't have to know that shit. You just have to solve this. Right? But that's really what's going on. That's why it makes sense. So the main thing to not mess up there is don't mess about up or down for parabolas. You gotta let that be easy. I'll understand a little bit if you mess up on some of the work to find the intercepts, but at least know how to start it to find an intercept. So the last class I took, math, what was it, 696 I think, or whatever. Yeah, baby. We had an equation with like 13 letters in it. And they wanted us to solve for the w-intercept. So how did I do it? I made all the other freaking letters 0. That's how you always find any intercept, is you make all the other letters 0. How do you find the y-intercept? Make x 0. How do you find the x-intercept? Make y 0. Because we only got 2 freaking letters in these things. But I don't care if there were 28 letters, because we borrowed some from Russian. How do you find some intercept? You make all the other letters 0. That forces the B on that axis. Don't forget, that goes through all of math. Right?
I have a question for 3G on the practice.
Yeah. Let me just put my extra practice test. There. Anybody else see the practice test while I'm thinking about it? Good. You need one? You're good? Or you need one?
Wait, you go back, right?
On the back, yeah, exactly. On this side is stuff we did in class.
Thursday, right?
Yeah. And this side is a practice test. Cool.
So is this not accurate when it says the test is going to be on sections 3.3 through 4.5?
Oh, no. So remember, we sucked that section 3.3 into the last test.
Okay, but, and then it says through 4.5, but we didn't go over the quadratic stuff on here.
Oh, like quadratic formula stuff?
Yeah.
So what's going to happen is where it says that section where it says solve, I got on part C, I just made up an equation. I was going to let it just be a quadratic, and I got lucky and it actually factored. So what you'll see on like the number 4 where it says solve on the practice test, you're going to get an example like this. Well, on the test, you'll get something that looks like this. X squared minus 3x plus 7 equals 0. Something like that. Let's make this a minus. Poop. Can I factor this? What do you need to factor this? You need... Well, all right. GCF, is there a GCF? No. No numbers, no letters, no GCF. Can you factor this? You would need 2 numbers that multiply by 7. What's the only ones that do that? 7 and 1. Can they ever make negative 3? No, I don't care how you put them together. They ain't going to make negative 3. So I really want this understood. Why does quadratic formula exist? Because you use it when factoring doesn't work. That's why the answers look so gross. If factoring works, I'm going to get nice fractional answers at worst. Quadratic's going to come out with stuff like negative 2 plus or minus the square root of 11 over 27. Holy crap. Why does it look so gross? Because it wasn't factorable. So it can give you all the answers that are gross. If it's factorable, I'll do that. Get the nice answers and be done with it. So why does this sucker, what is this? What is quadratic?
Are we going to need to memorize that?
Hell yeah. Negative b plus or minus
Square root. B squared minus 4ac over
2. I like it. How's that going to help me buy this? Whatever. It's not the point. Right? This is an invention of humans. You're in math class. You want a degree. You need to know this. You know that we did this. We made it. Rah. Plus, if you don't like all that, you need to know it so you can get that question right on the test. Blah, blah, blah. All right. And so now it's just plug and chug. So here, what's A for this problem? 1. What's B? Negative 3. And what's C? Negative 7. How do you know that? Because it's ax squared plus bx plus c. That's the general form of those trinomials that we're working with. So then I just plug those numbers in. We go to 10, right? So here it would be negative b. So negative 3 is 3. Give or take, negative 3 squared minus 4 times 1 times negative 7 all over twice 1. So you just got to really clean this shit up and you're basically done. Maybe 9 plus 28 is 37. So you get 3, give or take, square root of 37 over 2. So real quick, just to bring back what I was talking about earlier with these, which way does this polynomial, which way does this parabola open? Up or down? Up. How do you know that? Positive x squared, right? What's its y-intercept? 0, -7, look at that. A little tear for the point that was given me. I like that. So -7, 0, -7, bam! Opens up. So it's going to have there are 2 numbers here, right? Now just get a feel for this. Isn't square root of 37 just a little bit more than square root of 36? And square root of 36 is 6. So 3 plus 6 is 9 divided by 2. It hits it at 4.5. Just about. And 3 minus 6 is -3 over 2, -1.5. It also hits it, -1.5. So that means the vertex must be in the middle here somewhere. Goes down and then back up. Did you have to know any of what I just did to do this problem? No, because we did it. I'm explaining why it makes sense. We got 2 answers again, just like we did earlier. The y-intercept is down, it opens up. It's got to hit the sucker in 2 places. Does it hit it in 2 nice places? No. Where could it hit the x-axis? Any damn where it will, right? So does it have to be 7 and -2? No, it could be this disgusting collection of answers, right? Of course, because it can hit anywhere it wants to. Shit. Again, when we got this answer, did you know anything of what I just said? No. So you can get the answer. I just also want you to realize what it means. Now what's really neat, which unfortunately you guys are not going to get, is what if the parabola starts up here and then opens up? What are the x-intercepts? Don't overthink it.
0.
There are no real intercepts. They will be imaginary. And imaginary is an unfortunate word. When they first came up with the negative numbers, some people said, they don't exist. What this shit is negative? Are we all cool with negatives nowadays? Of course we are. We understand negatives mean like debt, unfortunately, and we all were like, why did they have to invent that shit? But it's physical. It means something. Negative profit means the company lost money. So we're all cool with negatives. But a lot of people were like, those were imaginary. And then they found out that this actually has a meaning. And unfortunately, the imaginary term stuck, which is stupid. It's not imaginary. It's real. It actually exists. But that's all I'll say. I'm sorry. I went on a little rant about the word imaginary sucks. Because when students hear that, they're like, I knew they were making this shit up. But it's just an unfortunate word that got stuck by people that didn't understand what the mathematicians were doing. There are actually other mathematicians that were just like, poppycock. And we're like, shit. They used words like that back then. Yes?
So when we answer this on the test, the answer will be 3 plus or minus.
Yep. Cool. I like it. Now, real quick, let me see. One more example of that. And watch this. Can you factor this here? What you got, Jeff? Yeah. Sure. Yeah. Let's do that. Can you factor this one? Yes. Yeah, it would be x factors of 3 to add to be -4. 3 and 1 make 4 if they're -4 if they're both negative. So what are the 2 answers? X equals 3 and 1. All right, now watch. Now, please, dear God, do this way. But the quadratic formula works always. It gives you the ugly answers that I can't get from that way. But if I use it here, what's A? 1. What's B? And what's C? 3. Negative B. -4 is +4. Give or take square root of B squared, 16, minus 4 times A times C, all over twice A. That's going to become 3 and 1.
So would you get mad if we did it that way?
A little bit. Maybe a lot. I might even say in the thing, solve, do not use quadratic formula. Because I gotta make sure you know how to factor. That's a little more important than quadratic formula, right? And teachers we gotta be careful when we say that kind of thing, because what students hear is, that doesn't mean anything, ah. No, but factoring is a little bit more important than that. But still, watch. What do I get? 16 minus 12? 4, and the square root of 4 is 2. 4 plus 2 is 6 divided by 2 is 3. 4 minus 2 is 2 divided by 2 is 1. Same freaking answer. Of course it's the same answers. Because when does this work? When does this solve any equation? Always. It always works. But I'd hope to God you guys would do it. This was quicker, wasn't it? Wasn't this quicker? Hell yeah.
That's stressful.
But sometimes people don't know how to factor. They learn this and then they just do this everywhere. That sucks because factoring is a little more important than this. So, yes, I'll probably write it that way. Do not use quadratic formula for these problems. Yeah.
Talk about either A or B for number 2.
Oh, yeah, we talked about B earlier. What makes something not a polynomial? Can you give me an example of something that's not a polynomial? Because the question here is, are these polynomials? So you got to know what makes something not a polynomial to answer that.
Is that something to do with the exponent? So they have to have more than, I'm guessing, 1 or 3? 2?
They have to have whole number powers. So this is not a polynomial. This is not. Because of that. This would become 1 over x squared, and then I wouldn't be allowed to use what value of x? What can I not put into 1 over x squared? What value of x can I not use? Because I can't divide by it. What can you not divide by? You guys are going to be like, I can't divide by 37.2 real quick. No. What are you not allowed to divide by? 0. So what can x not be? 0. So polynomials, I want them to be defined everywhere. I want every value to work. And I also want them to look nice. I want them to look like, oh, such gentle rolling hills. I don't want them to look like this. I don't want them going to infinity or something weird. I don't want them to have this, I don't want to be in that plane, right? We're all dead. We're dead. I want them to be nice, like that. Oh, nice. Right? Like a little roller coaster. It's fun, but nobody dies. Right? So requiring that the powers be whole numbers makes that happen. That's what it does. So that doesn't work. What about this one? Is that a whole number? No, it's a fraction. It's irrational. It's rational. It's not whole. So no, that's not a polynomial. Okay. So it's all about the power that is on the variable. So in number 2b, we talked about this earlier. Why is that one perfectly fine? It's totally a polynomial because every b term has a whole number power. That over 3 doesn't matter worth anything. The coefficient can be anything I want to be. So is this a polynomial? Yes. Is this a polynomial? Of course. The x is still to a first power. It's not on the bottom, right? So just because one of the numbers is a fraction doesn't make the whole thing go to hell. Yes?
So if the exponent is positive, it is a polynomial.
If the exponent is positive or 0.
Or 0.
Yeah, because again, is that a polynomial? Yes. 1 is a polynomial because it's 1x to the 0. So that's why officially we call it has to have whole number powers. And also, be careful, not just positive, but whole number, right? Ronald, it can't be 3/4. That's positive, but it's not a whole number. I like polynomial. So 2b is fine. What's the only one in there that's not a polynomial on number 2?
C.
C.
And the degree would be
Well, for C, screw the degree. It's not a polynomial. I'm not going to, you just say no and be done with it. Because see, I was saying, if it is, then do this extra stuff. There's no point to talking about degree if it's not a polynomial. Yeah.
I know you just did factoring up there, but could you do one more problem for 3? Doesn't matter which one.
For which one, sir?
For number 3 on the practice test, I mean
It's
the.
F.
Oh, all right. So 3F. What's a y squared? You can do something, but it's only one little thing you can do here. Why can you not factor it like you would this? I mean, how does this factor?
X.
Yeah, why does it work? Because these can be opposite signs because this is a negative. So can that work the same way? No. Sum of squares cannot be factored unless, of course, there's a, what's the first thing you always try? GCF. What goes into 16 and 100? 4. So you can take 4 out. And that's all you can do. So other than that, it's a sum of squares. That doesn't go anywhere.
So how would you take that out? Just put
Take it out. 4. Can you take an X out?
I mean, no.
No, this is just GCF. I can't break it up like this because it's a sum of squares.
So,
But I can take a GCF out. And then what's left here? 4, x to the 4th, plus 25, y squared. Sum of squares, you're done. If that would have been a minus sign, then I could have gone further after this step. Right?
that's so.
But again, why does difference of squares work? Because the minus sign allows these to be different signs. Why is that important? So the middle term cancels.
So for G, you can't do nothing about it.
But yeah, G is different than this, right? Why does G not work? Because what do you need to have happen? You need two numbers that, for part G, multiply to be 2, and add to be, I don't know, I mean, I try to make it really, really obvious. Because it would really suck for me to give you a problem, you're not sure, and you spend like 10 minutes on it, and you come up, I don't know, it's prime. Get away. Oh, shoot. It's almost time to turn it. So, I'm going to try to make it obvious. Right? No. So there's no factors of 2 that add to be negative 45.
So what do you put?
That's like accounting level mysticism.
What that's
Prime. Cool.
okay.
So probably at most I would give you 1 prime problem. I love it when somebody turns it in, and out of 8 factoring problems, 6 of them they said were prime. I am not gonna do that. So
And then the question for 3D.
3D.
Yes.
Okay.
So what happened to, I can check the GCF at X and 16.
There's no GCF, right?
Yeah.
Okay. All right, guys. So there's no GCF. How many terms are there? 2. So what could it be? It could either be squares or cubes, right? Now I told you earlier the cubes will be in the bonus section because the book doesn't have any cube problems, and I figured that would be evil for me to put one that you didn't get a lot of practice with. So you're pretty much going to know if it's 2 terms, it's going to be squares, right? If anything. It's different, so I know squares will work. So now you just cut everything in half. X squared, minus plus 4y squared, 4y squared. If you circle that, you'll lose points. Why? Because I'm a math teacher and we're all evil. That is true, but here I have an actual reason. Why would you circle this? Why you lose points? Because this one is a difference of squares still, right? So again, it's not I really hope you understand. It's not evil. It's not hiding anything. If I said factor 18 completely and you said 9 times 2, it's really obvious why that's wrong. 9 goes further. Same thing. Same thing. Does this go further? Yes. If it does, you better do it. All right? So how do I factor this little dude? Same way I did that one, really. Cut it in half. Minus plus. 2y, 2y. And this guy comes for the right. So I rewrote this whole thing. I rewrote it, but I rewrote this in a different form. That's all I did. I can't lose anybody because I have to be able to multiply it all the way back up to here. So if you just write this, you're also going to lose points.
So you did that because there was a negative?
Yes. It says difference of squares, which allows these to be different signs, which allows the middle term to cancel. That's why only difference of squares works. He just goes by each door and says, all right, let me go ahead and give you guys an answer key. It sounds like a decent number of you can try this stuff out. If you're in the process of trying this practice test out, don't even look at these answers. Put them away. Don't even look at them. Yeah, false confidence sucks.
So, for...
Oh, yeah. Do you do those two?
Yeah, do these two and then the other one?
Yes.
Okay.
If I said, what's 2 times 4 times 7, there's no way you can do all 3 of them at once.
Yeah.
You'd have to do 4 is 8 times 7. Cool. I like that. But who? No, you mean like the answer for a factor? Oh, not really. I'm not going to force you to put it in descending order, but I sort of do that sometimes. Like part D, it's not really. It's ascending order, so I just look to make sure you got all the terms that you're supposed to have. Then I grade it. By the way, number 2, the only leading coefficient that isn't 1 is part D. It would be 5 because it's the only thing it's got. So I just forgot to put the leading coefficients down there. Oh no. I also made a really dumb mistake on 2D. Somebody help me out. Apparently I don't know how to count. How many variables do you see in that? None. I don't see any variables. I see a 5. Yeah. So I got first degree. It should really be a... How many variables do you see? None. So it's a 0th degree.
If you put binomial, would you still get it wrong?
Say again?
Would you put binomial by itself? Is it wrong?
Well, I need the degree.
No.
Yeah.
So 0?
Yeah. 0th. 0th. choose. You have to multiply both sides by the same thing. So you multiply by 4 and it distributes to each one. Yeah, cool.
For G, I don't know what I did.
Oh, alright. So what's like 5 squared? What's 5 squared? 25. So if I had 2 plus 3 squared, it should still be 25, right? Because 2 plus 3 is 5. Alright. But if I do this, 4 plus 9, that's 13. So either 13 equals 25 or this is wrong. This is wrong. So when you see this, x minus 4 cubed, what does something cubed mean? It means that thing...
Also, I have to write.
foil these, and then take the answer and multiply it by x minus 4. So if I said, no calculator, what is 11 cubed? How do we start to do 11 cubed? You would do 11 times 11, and then take your answer and multiply it by 11 again. So do x minus 4 times x minus 4, take your answer, and multiply it by another x minus 4. I like it.
So I just saw it like whatever. I was like, yeah, whatever. Just play.
Yeah, because powers can't distribute across minuses because they're not built based on addition or subtraction.
Did you?
Yeah.
I think this stuff right here,
Oh, this ran out of room, but I mean, you just take x squared times x, that's x cubed. Then what I did was x squared times negative 4. Negative 4x squared, negative 8x times x is negative 8x squared, so I get negative 12x squared total.
so I erased you this time.
Yeah, that's why I hate FOIL, because I don't care if one of them has 3 terms, 4 terms, 8 terms, you take each piece and they each get a term. So the x squared gets to distribute through the x minus 4, the minus 8x gets to distribute, so forth, yeah. Just repeated distribution. Much better than FOIL. Yeah. This has 2 x's and a y. This has 2 x's and a y. They're like terms.
This one would be 2y or just 1x?
That would be like terms of this one. Yeah.
This one
So this is just out of alphabetical order. If you put them in alphabetical order, they're exactly the same. Right? Because it doesn't matter what order you multiply in. Y times x squared is x squared times y. And then you can really see that they line up.
So as long as I have
The same variables and the same amount of each variable. And they're like terms. Yeah. Yeah. Oh, snap. Thankfully, there's like 4 or 5 problems from there. And it's pretty quick. If you've done 4 or 5, you should agree. Aww. It's just, are they opening up or down? And find the y-intercept. That's it. It should take you like 3 minutes. Yeah. If it takes you 4 minutes, you should feel really bad. Now you got that on tape. Yeah. You multiply it by the 2n. 6 times 2 is
12.
It's gonna be on all of it.
And where x
beautiful. That's it. And then you keep going. So it works just like that. Oh, this one is you see how it's 2 terms, you break everything in thirds. So that's a cubes problem, so that would be like a bonus question.
Oh, okay.
Yeah. Same thing with this guy, this would be a GCF and then a cubes problem, because you can break everything in thirds.
Oh, okay.
Yeah.
All right.
What do you always try first? Yep. So do that first. What number comes out of all three? Are they the letters that come out of all three? Yep. And then what you're left with will be really nice. You're getting all the extra crap out of the way. Yeah.
Where did the 3y come from?
So this will be x, x, x. This will be 3y, 3y, 3y. Other than the thirds. Yep. So you got 1x and 1 3y. 2 x's and 2 3y's.
I would think we all realize that. I don't know why. Let's see, negative 3xy plus 9 squared plus cy. That's cy losing 27x.
Yep. Yeah, there's the 1y and the other 2y's makes 3.
For this side, yeah, I'm still confused.
So again, 27 is 3 times 3 times 3. So 1 3 goes there. Y cubed is y times y times y. So 1 1 goes there. So then the other 2 3's and the other 2 y's go over here. So then when you multiply these together, you get 3 of each again. They become this again. Real quick, just make sure you guys know, you understand 3b, 3b, and 3h are examples of cubes. So they're going to be problems that would be bonus on the test, like I said earlier. So 3b and 3h are cubes. So if they're on the test, they would be in the bonus section. So you can, if you're having trouble in those, you can feel a little less bad about that. If you do them really well, you might get some bonus points.
Okay, well, I have a question for this one. Did you say that they would minus and plus for the answer? Or
You're thinking about when you take a square root.
that's what I was thinking.
No.
Oh,
You're not done, for one thing, you're not done factoring. You got to finish factoring before you set things equal to 0. Or even more basic than that is, you don't have to do it the way you're doing it because the first term is just a 1, right? So what I'm saying is this is x squared. There's only one way to make that happen, x times x. Now what numbers did you find that works? 11 and 3, and they both have to be,
negative?
right? So either x minus 11 equals 0, or x minus 3 equals 0. Well, you broke the middle term up and then tried to group. You didn't finish factoring, so then that threw you off about how many answers you should get. Yeah.
Like, do these cancel it?
Yeah.
Alright.
And if you think about it, that's sort of like, that would be little b big 2. So that's why it makes sense that a lot of stuff cancels. Right? It's sort of how we learn how to factor this. But you don't have to know that before you start the problem. Yeah, so you get that stuff, and then you just distribute each one of these through. Sure. Let's see. So you get plus 16x plus 32x.
Do you have an extra practice?
And then 5x equals 0, or x minus 2 equals 0. Yeah. Oh, yeah. Well, that has to equal 0 to make this whole thing 0. That number's 0, or that is 0, or that is 0. Now to solve this, it's not as hard as you might look. Because the only thing x could be to make this 0 is 0. Yeah.
So Tuesday's no class, right?
Say again?
Tuesday's no class.
Thursday.
Like Thursday. Yeah. Why is there no class?
Because I have to leave town, and I figure
Can you sit there?
I don't have to get a substitute for that day. You guys can take it off. Plus, it gives me a little extra time to grade your tests.